Welcome back to my channel. In this video, we'll be configuring port bundling or port channeling using LACP, which happens to be Link Aggregation Control Protocol. Link Aggregation Control Protocol allows us to combine multiple physical links into one single logical link for increased bandwidth and redundancy between switches. I'll walk you through the step-by-step process of setting it up. Then we're going to verify the configuration and also explain how it improves both performance and fault tolerance in a network. With that being said, let's get into the video. Okay, I mentioned what LACP allows us to do. Again, like I said, allows us to combine these 4 physical links into one logical link. So that is pretty much what it does. And why do we want to do that? So we can increase bandwidth. Just think about it. Let's say you had a laptop. You put one charger in. You had a MacBook laptop. You put one charger in. It charges, right? But let's say you put in 2 chargers. It's going to charge even faster. It's kind of the same thought process. You take one of the chargers out. It's still going to be charging. That's that redundancy part that I'm talking about, that fault tolerance. So, I mean, the more links you have, the better for increased bandwidth or speed. And again, if something is, let's say one of the links are faulty, it's still going to be able to send that communication or send that data over to the other side because because one link is down, it's still able to send that because of the fault tolerance that it has. So just think, that's how I think about port bundling. Yeah, just a laptop, put in 2 chargers, it charges the laptop pretty fast, increase bandwidth. Take out one of the chargers, it's still charging because you still have that one of the other links still there. So it's pretty much the same thing. That's what port bundling does. But let's get into this video. I'll show you guys how to configure it, and yeah. So go here. It looks like, oh, I was already here. Okay, so we're in config mode. All right. What I will do is, let's take a look at the interfaces that we have. Do show IP interface. I'd like to do brief. Let me go ahead and X out that. Make that brief to summarize. All right, cool. As you can see here, ports that are assigned are 1, 2, 3, 4, and that's what I have here. Yeah, and if you pull up the other one as well, it will be the same thing. Will be the same. Do show pint. There we go. Same thing. It's up, connected. Cool. All right. Let's go ahead and attack them one by one. Okay. But now we need to create a port channel interface. So for us to create a port channel interface, what do? We go ahead and do interface. This port channel. Channel 1. Cool. And we go ahead and assign the IP address that we have here for our port channel. 192.168.0.1 with a subnet of 30. Subnet of 30 would be 255.255.255.2 32 minus 34, 2 raised to the power, no, it's 2 raised to the power 4 is 4, 256 minus 4 is 252, so yeah, it'd be 252. So we add this IP address. Oh, I know why it didn't work. You know why? We need to turn off the switch port, so no switch port. Add that IP address again. That worked. All right, there we go. Now, if we go ahead and check in the brief, we should see that port channel 1 that we created. IP address to be assigned to it. It's down. It's down. Now I could go ahead and do a no shutdown on that interface. No shut down. Let's go back and check. It's still down because you need to configure port channel on the other one for it to. Yeah, we need to configure it on the other one, but we'll get there. But yeah, it's gonna go once we configure it on the other one. It'll go up. Next thing we're gonna have to do is basically configure the physical interfaces. So there are 4 of them. We want to bind these into a logical link. We could do them one by one, but no. What we're gonna do is basically do interface range. Call them all out at once. Fast. 1 to 4. So we'll call it the whole range. You see the difference between this one. It's dealing with a single interface. This one we're dealing with a range. So whatever we do here, whatever we do in this mode will apply to all 4 of those ports. So no switch port first off. No switch port. And then ports. Wait, no. Regular port channel. Channel group. That's what it is. Channel group is the command channel group. 1 mode active. You have to set it to mode active because it's the one sending them. So you have 2 switches. It's either they're both active or one of them is at least active because something has to send to initiate the passive one. If they're both passive, it's not going to work. So you can either set both switches to active or you can set one to active and have the other one be passive. Again, the active one is be doing the sending and the passive one will be doing the receiving. So if you think about it, if it's both passive, no one's sending anything. It's just receiving. So yeah. So we'll set this to active. They're all active now. It went down, up, down, up, down, up, down, up. So cool. That has been configured. Port channels have been configured in this one. So we do the same on this side. You see it's up. But we need to create the port channel. So port channel 1. Port channel 1. Port channel 1. Interface port channel. There we go. If we go ahead and check this, you'll see it's there now. There we go. But let's go ahead and configure it on the physical links. Interface range, like I mentioned. We're gonna hit them all at once. 0/1/4. Voila, we're in that range. So now we want to do a no switch port. No switch port. No switch port. Voila. Up, down. Cool. That's a good thing. I'm gonna put this down here. This is already been configured. And now what we're gonna do is channel dash group 1 mode passive. We can make this one passive. As long as one of them is active, we're okay. And you can make both of them active if you want to. See that? Oh, rejected. Why is it rejected? Ether port is L2. ether port L2 and port channel is L3 or vice versa. Did I do a switch port on the other one? Or what if I do this? You know what? I know why. I didn't configure an IP. Wait, hold up. Did I configure an IP? I didn't configure an IP. Hold up. Oh, I didn't assign the IP. That's why. I got ahead of myself. So let's assign the IP. IP add 192. Okay, no switch port though. Add IP 192.168.0.255. 255.255.255.52. We do no switch port. We did no switch port. I know what I'm doing. I didn't see that. Why didn't I see that? It's the IP add. There we go. Okay, so let's go back to exit this. Let's go back to those 4 ports: interface, range, fast, 1, 2, 4. All right. Do no switch port channel group 1 mode passive. There we go. That's been configured. Let's verify. This up, okay. Show ether summary. Well, it's been configured. I know why. I need to put a do show. You see it's been configured. You see the protocol has been configured. And you see the 4 ports where they're connected to. So there we go. And let's run another command, another way to confirm. You do a do show interface port / channel 1. There, okay, there we go. See the numbers in the channel. Those are the numbers that we connected to the channel. Take a look right there. Yeah. So that again tells me that we did what we needed to do. And we can also do a show. That's literally how you, that is how you do it. If you want, we can test it to see what happened. I wanted to test it. Oh, let's confirm something. Yeah, everything's up. Let's see the other one. To show IP and up. So if I were to do a ping 192.168.0.2, I do. Should send the packet over. Yeah, it got there. 80%. Let's try it again. Get there. Voila. Success rate. We're able to do that. But let's see. Let's do this. Let's do a no shutdown of one of the ports. Alright, or two of the ports, if anything. Let's go interface range. Interface range fast 0/1 and 2. Yeah, let's shut these two ports down. Oh, fat finger. There we go. We do shutdown. Those two ports. Right, and let's confirm that the ports are shut down by going internet brief. Those two are administratively down, but these ones are still up. Let's run that ping. Let's run the ping. Still got there. Why? Because although these two are down, these two are still running. So these are down. These two are still running. So that right there explains port channeling. Again, link them together, they're bound together. But I mean, and yeah, you link them together, they're bound together. They increase bandwidth. That's the fault. It increases bandwidth, and then the fault tolerant piece is what we just went through right now by shutting down ports 1 and 2. 3 and 4 still up, and it's still able to send the data or the frame over from this side to that side. So and back. So this is port channeling. Another thing I need to note: the amount you can only do about in one logical link. You can have about 8 physical links within one port channel. That's the maximum, I believe. But yeah, this is port channeling with the LACP. If you have any questions, drop in the comments. If you have any questions, drop in the comments as well. Yeah, thank you for watching, and can't wait to see you guys again.